Hello everyone, I am Nandini Ramesh Kota. So today we are going to see what is the DHCP server. So let us see exactly what is DHCP. DHCP stands for Dynamic Host Configuration Protocol. DHCP is a network protocol used in most networks today. Its main job to automatically assign IP addresses to devices when they connect to network, like when you connect your phone or laptop to Wi-Fi. Why DHCP is important? Why DHCP is helpful? Because without DHCP we would have to manually assign IP addresses to the network. Every device imagine doing that for hundred of computer. DHCP makes this process automatically and eliminates the need for manual configuration, saving the time and reduce errors. DHCP helps device join network easily and communicate properly. It doesn't just assign IP addresses. It can also configure other network settings like the default gateway or DNS server. And this process simplifies network management for IT administrations and ensure that device can connect quickly and efficiently. Let us see why DHCP is needed. DHCP reduces the network administrator workload. Without DHCP, Without DHCP, an admin would have to go each computer or device and manually enter IP addresses, subnet masks, DNS, and other settings. That takes a lot of time and efforts, especially in large networks. Second one, it helps to prevent the IP addresses. If two devices accidentally get the same IP addresses, they won't be able to communicate properly on the same network. DHCP automatically manages IP addresses to make sure every device gets a unique one. Third one is essential in network with many devices, such as in office, schools, or universities. Imagine hundred or even thousand of devices connecting, managing them manually would be nearly impossible. DHCP handles it quickly, accurately, and efficiently. Let us see how DHCP works. Uh, Now let us understand DHCP actually works. The whole process happens in just four main steps, and it usually completed in just a few seconds when device connects to network. First one is a DHCP discover, second one is a DHCP offer, third one is a DHCP request, fourth one is a DHCP acknowledgement. Let us see one by one. First one is a DHCP discover. This is the first step in DHCP process. It's called DHCP discover. When a device like a computer, phone, or printer connects to network, it doesn't yet have an IP addresses. So it sends out a special message called a DHCP discover. This message broadcasts to entire network, which means to goes out every device connected. The purpose of this message is simple. To device the basically asking, is there DHCP server out there that can help me get an IP addresses. This is important because it helps the device find available DHCP server that assigns it the proper IP settings. Let us see the DHCP offer. This is the second step of DHCP work process. This DHCP server responds to the client. The server sends a message called a DHCP offer, which includes the important network setting that the client needs to connect. The offer contains things like an available IP addresses for device, the subnet mask, which helps define the network, the default gateway, which is usually router address, the third lease time, which is how long the IP addresses will be valid for, and possibly other information like DNS server settings. Let us see the third step, that is nothing but DHCP request, um, uh, which is called DHCP request. At this point, the client has received an offer from DHCP server. Now it's need to respond, and that's what happens here. The client sends a DHCP request message back to the server. This message simply means, yes, I accept the IP address and settings you offer me. It confirms that client wants to use the specific IP address that was offered in the previous step. This step also helps avoid confusion if multiple DHCP server made offer. The client picks one offer and sends a request back to the server only while ignoring the other. Second, fourth and final step is nothing but a DHCP acknowledgement. This is final step. In this step, the DHCP server ends a confirmation message back to the client. This message is called DHCP ACK. What does this acknowledgement message mean? It means your IP address is confirmed. You can start using it. At this point, the client has everything. It needs an IP address, subnet mask, gateway, and any other necessary things. And it can now communicate with other devices and network or access the internet. To quickly review the full process, discover the client looks for server, offer the server makes an offer, request the client accept the offer, acknowledgement the server confirms it. The entire process is known as a DORA, which stands for Discover, Offer, Request, Acknowledgement. Let us see what is DHCP lease renewal. DHCP now client has an IP address. That IP isn't assigned forever. It is leased for a limited time. This is called a DHCP lease. Means the IP address whichever given by the server, it is for particular time. We can say it is a temporary purpose. Before the lease expires, the client tries to renew it. Why? Because the lease ends and the client doesn't renew. It could lose its IP address and get disconnected from the network. Here what happens, the client sends a renewal request to the DHCP server and the server replies with a DHCP acknowledgement confirming that the lease time has been extended. This process helps the network manage IP address efficiently. It ensures that unused IP addresses eventually return to the full and can be assigned to other devices. Let us see the message exchange diagram. This is the message exchange diagram by DHCP step by step. And this diagram gives us clear step-by-step visual how DHCP works between a client and a DHCP server. The first DHCP discover client sends broadcast request for IP. In DHCP discover, the client sends the request for server for getting IP addresses. Second, the server reply to client. Server replies with an available IP offer. Whatever the IPs are present in server, that gives to client. Third one is a DHCP request. Clients request that offered IP. The client send message to server. Whatever the IP address given, it is accepted to me. Fourth one is a DHCP acknowledgement. Server confirms that assigned IP. Whatever the IP address is given by server, it confirming the assignment of IP addresses. Let us see the DHCP component. First one is key components that a DHCP server manages. There are building blocks that allow to assign network settings automatically. First one is IP address pool. This is the range of IP addresses that the server can assign to device. For example, it might be from 192.168.1.100 to 192.168.1.200. Each time a device joins a network, the server picks an available IP from this pool. Lease time is nothing but this is the amount of time a device is allowed to use assigned IP addresses. Third one is a subnet mask. This helps the device understand what part of IP addresses refers to the network and what part refers to the host. This is essential communication within the local network. Gateway and DNS server info. The gateway is usually the router's IP address. It allows the device to connect to internet. The DNS server translates domain names like www.gmail.com into IP addresses. These components are include DHCP offer and ACK messages. So the client is fully configured to communicate both inside the outside the network, all without manual setup. Let us see what is the where DHCP is used. DHCP is used in home networks, Wi-Fi routers. Corporate networks is nothing but the company or corporate means companies, MNCs. Schools and universities nothing but colleges, schools where the routers are used. Data centers and cloud networks is nothing but the database labs, data centers where the servers are where our servers are present. Internet service providers. Let us see advantages of DHCP. First one is a easy network setup. Device gets IP automatically without manual configuration. Second, centralized control. All IP settings are managed from a single DHCP server. Scalability works efficiently both for small and large networks. Efficient, e- efficient IP manages. efficient IP manages, prevents IP conflicts from tracking usage, simplifies IP addresses management, no need to assign and track IP manually, reduce configuration errors, automation minimizes human mistakes, efficiently allocates IP in large networks, handles thousands of devices easily, supports mobile and dynamic devices. It's perfect for laptop and smartphone that move between networks. Let us see what is the limitations of DHCP. Relies on central server scalability availability. If the DHCP server goes down, new device can't get IP. Not ideal for static IP needs. Example, servers usually need fixed IP, which DHCP doesn't handle well. So third one is a can be misused if not secure. Misuse or not secure, because sometimes IP get attached or give by others device, so it can be misused. So let us see the practical example of DHCP server. So here it is a network topology overview, which is a star topology. In this image we used devices in network. In this image there are devices. First one is a switch. This is switch, and PC laptops are nothing but the end devices, and third one is a server. These are the three important devices in network. This switch acts as a central device, acts as a main hub through which all network traffic flows. From from this device all the network traffic flows to each end devices, connects all the end devices, PCs, laptops, and allows communication between them. This switch is allowed to communicate with all devices. End devices are nothing but this PC and laptop. PC0, PC1, PC2 standard desktops computers communicated connected to this switch, and laptop 0 and laptop, this is a mobile computing device also connected to the switch, and this is a server, provides a for network services such as files such as files sharing, web hosting, or email. This server assigned the IP addresses shown in 192.168.0.0. Likely the network address, not the server's specific address. The server's probably has an address like 192.8.16.0.1. Or similarly. Here is the connectivity status, which that green arrows indicate that devices are successfully connected and communication links are active. Envelopes with green checks show that the data like ping or email is successfully transmitted between the devices. The blue envelope on laptop 0 might represent an other communication protocol test in the progress. The key concept for this presentation: star topology, switch functionality, server role, and IP addressing, packet tracer tool. And in network topology, that red cross marks on envelopes, this symbol shows that the packet transmission failed between devices. Possible reason: devices are not configured with IP addresses, wrong subnet configuration, or missing uh, or missing default gateway, server misconfiguration. Device might be turned off or network interface are disabled. No DNS or DHCP service. These are the practical explanation or practical oriented of DHCP, how working DHCP server. This is the practical. So let us see conclusion. DHCP automates IP configuration. Crucial in modern dynamic networks, because in dynamic networks DHCP plays a vital role, enhances efficiency, reduces errors.